If you're a Node.js developer and you're interested in learning Golang, stick around because in this video, I'm going to show you the basics of Golang for Node developers. So who is this video for? It's for those that are familiar with Node.js and interested in Go. It's for those that are familiar with Express.js, those who know what Go is, and those developers who want to start using Go. I'm not expecting you to be an expert Node.js developer. However, a basic understanding is going to help with the comparisons. So what will you learn? You're going to learn some basic Go syntax. You're going to learn the basics of how Go compares to Node.js. And you're going to learn some basic folder structure that's going to help you build your applications. So what technologies are we going to be using? We're obviously going to be using Go. And we're going to be using Fiber, which is an Express-inspired web framework. There's a few different web frameworks, but I'm going to use Fiber because it is very similar to Express. And so if you have a bit of an understanding of how Express works, Fiber is going to look very familiar to you. And we're going to be using MongoDB, and then we're going to be using Postman to test our API. So before we get started, I'm going to show you a JavaScript version of the API that we're going to be creating with Go. So we have a main.js file. And you can see in this file, we're initializing Express. We're using the Express body parser. We have a couple of routes here, one to create a product and one to get all products. And then we're starting the application on localhost port 4000. We're going to connect to the database, and then we're just going to log ready for work. Then we're going to execute this main function. So if we have a look in products, you can see that we have two handlers here, one to create a product and one to get all products. And I'm just using MongoDB here. And so we're going to get the collection, then we're going to create a doc object, and then we're going to insert that doc object. And then we're just going to send back the result. And for get products, we're going to, again, get the collection, and then we're going to iterate through the cursors. We're going to define this products array, and then we're just going to push each product to that array. And then we're going to send out the array of products. So then in our database, we're going to initialize our connection. And then we're going to export a client.db. And we're going to export that database, and we're going to export the collections object. And this is essentially just an enumerator that is going to define the collections. Finally, we're going to export the connected DB function, which is used in our main function. So this is a very simple API, but hopefully it will give you a bit of an understanding of how Node.js compares to Go. So let's first initialize our application by typing go mod init, and then I'm going to start with a domain. You can start this with github.com, and that's pretty common. I'm just going to use example.com here, and then I'm going to call my application tom.does.tech. So once you've created your Go module, you can see that we have now a go.mod. And then up here, we're defining a module. And this is what we called our module, example.com/tom.does.tech. And in this command here, go mod init, this is going to match exactly the same. And then we're just going to define what version of Go we're going to be using. I'm going to install the Fiber module so you can see how that modifies this go mod file. So I'm going to type go get -u, and then I'm going to type github.com go fiber/v2. So once our module has finished downloading, you can see we now have a require statement here, and we have a bunch of other dependencies. And these are all just dependencies that Go Fiber relies on. So you'll also notice that we have this go.sum file, and this is just going to list out all the dependencies, both indirect and direct, along with their version numbers and their checksum. The equivalent for the go mod file in Node would be the package.json file, and then go.sum would be your package lock or your yarn lock file. So let's start by creating a main.go file. So I'm going to create a new file, and I'm going to call this main.go. And inside of main, I'm going to start with a package, and I'm going to call this package main. So at the top of each Go file, you're going to see this package keyword. And Go programs are constructed by linking together packages. And the package name does not need to match the file name or the folder name. The package name at the top of the file just denotes which package this file belongs to. Don't worry if that doesn't make sense yet. I'm going to go into a little bit more detail about packages later on. So let's define a function. So in Go, you just type func, and this is exactly the same as in Node where you would type the full function keyword. So then you name the function, and then you call your curly brackets. And in other functions, this is where you would put your arguments, but the main function doesn't have any arguments. So the first thing I'm going to do is just print a line that says hello world. So I'm going to type fmt, and you can see here that this is going to come from the fmt package. And if I press enter on this, VS Code is going to import fmt for me. So I'm going to type .print ln, and this is print line. If we go into the fmt package, you can see that we get some really nice descriptions above all of the functions that we have available. So we can print a line here that just says hello world. Now to run this file, I can type go run and then main.go. And you can see that we just get a line printed out that says hello world. So let's get started initializing our Fiber application. So I'm going to say app, and then I'm going to use a colon equals, and then I'm going to say Fiber. And you can see that VS Code has imported Fiber for me. .new. So an interesting thing changed here. So before we just had FMT imported, but now that we have multiple modules, we're going to use these brackets, and then we're going to have our modules from external sources below our modules that are part of the standard library. You can also see that VS Code is complaining here, and it says app is declared but not used. So if I try and run this application now, the Go compiler is going to throw an error, and it's saying that app is declared but not used. This is not allowed. Go is very strict with not using variables, and that's a really good thing in my opinion. If you compare this to Node.js, Node would just let you run this application, and it will just ignore the property that isn't used. So now we can use app, and if we press dot, you can see that we get a bunch of different methods on here, and these are going to look very familiar to Express. So you can see that we have a get method here, and we'll also have a post, we'll have a patch, and we'll have a delete, and these all correspond to their HTTP methods. So I'm going to say app.get, and then this is very similar to Express. So the first argument is going to be the path that you want this get to match. So I'm going to say /health check. And then we're going to supply a function that is a callback for the get method. So I'm just going to type func, and then I'm going to call my execution brackets. And you can see here that it's imported C, and this is Fiber context. And you can see here that we have an error. And this just means that this function is going to return an error. So I'm going to type c.send string, and my string is just going to be OK. So you can see that we have an error here still, and this is because we expect a return statement. So there's a few things to talk about here. The first one is you'll notice the capital G here. And if we command click into this, you can see that the function is defined with a capital G, and you'll see this app here, and this app points to another property called app. This looks very weird, and what this is telling you is that we have a struct here called app. If we command click onto that, you can see that we do indeed have a type app, which is a struct, and we're going to reference that, and we're going to call this app. So this just could be called anything. We could call this A if we wanted to, and you can see that would work. Of course, in the module, they've called it app. And then we've named the function get, and the capital G just means that this function is public. So if we made this a lowercase g, you can see that we're starting to get some errors here, and it's because that this function now cannot be exported. So we need to use a capital G to denote that this function is in fact public and can therefore be used in our application. So you can see here we have some arguments that are going to go into the function, and then we have whatever the function is going to return. And then of course we have the function body. So the next thing is this func, and you can see that this is an anonymous function. We haven't actually named this function. We can come up here and we can name this function. So we'll say func health check. And now we can pass that function into the second argument of our get, and this works. And in fact, this should be a lowercase h because we wouldn't want to export our health check handler. So let's run this application again. And you can see that it just prints out hello world and exits. And this is because, much like Express, we need to call this app.listen. So I'm going to say app.listen, and then I'm going to supply a string, and the string needs to start with a full colon. And then I'm going to run this app on port 3000. Let's also wrap this in a log.fatal. So I'm going to say log.fatal, and then I'm going to move my app.listen. And this is something that is not comparable to Node.js. This looks pretty weird. This is like executing a function inside of console log. So in Node, this would be doing something like console.log and then executing this function. Although you could do this, you don't generally see this happening inside of Node.js. And the reason is because console.log isn't really an equivalent to log.fatal. So what log.fatal is going to do is if the function throws an error, it's going to call print. So we can command click into this. Fatal is equivalent to print, but is followed by an os.exit1. So in Node.js, this os.exit would be something like process.exit, and then we would exit with a status of 1, which means that it's a fatal execution. So let's save this and we can try to run our application again. And now you can see Fiber has printed out this thing for us here. And it's listening on 127, so localhost, and then port 3000. And we have 2 handlers and 1 process, and then we have a process ID. Some really handy information here. Let's send a curl request to our application. So I'm going to say curl localhost port 3000 / health check. And you can see that we get back our OK message. So before we go any further, I'm just going to show you a very common setup that really confused me when I started working with Go. So in the root directory, I'm going to make a new folder. I'm going to call this cmd. And inside of cmd, I'm just going to move the main.go. So you can see here that we have a package called main, but it's in a folder called cmd, and this is perfectly fine. The next thing I'm going to do is to create a new folder, and I'm going to call this internal. So usually in internal goes all the other internal things that you're going to use inside of your application, and then everything comes together in your main.go. So inside of internal, I'm going to create 2 folders. I'm going to call this one DB, and this is going to handle all of our database stuff. And then I'm going to create a new folder called handlers. And this is of course going to be our handlers for create and get products. So let's do our database connection first. So I'm going to create a new file, and I'm just going to call this db.go. So we're going to be using MongoDB, so we need to install the MongoDB driver. Inside of the repository that you're going to be able to find on GitHub, there's going to be this notes file here. So you can see that in here we have our go mod init command, and then we're going to have our go get for Go Fiber. And we're also going to have a go get command here for the Mongo driver. So I'm going to execute this go get. And then inside of MongoDB, we're now going to be able to use the Mongo driver. So I'm going to define our package, and I'm just going to call this DB. And there's lots of ways you can set up this database connection. I'm just going to show you one way. I think that this setup is quite simple, and it also is reflected nicely in the setup we have here with JavaScript, where we create our client, and then we call client.connect, and then we export our client.db. So I'm going to say var, and I'm going to call this client instance, and this is going to be a star mongo.client. And you can see that VS Code has imported this for us here. So you're not going to get far in Go before you see this little star syntax here. And you may know that this is a pointer, and I'm not going to go into too much detail about what pointers are and what they do, but I will teach you a couple of little rules that you can use. So a star is just going to reference the value, and then we have the ampersand sign, and this is going to say point to the block of memory that stores this object. So I'll show you a quick example of pointers. So if we come back, we can say x colon equals 10, and then I can say y colon equals ampersand x. And this is just going to say that y points to the memory block of where x is held. Then I'm going to say fmt.print, and I'm just going to print out y. I'm just going to comment out where our app is listening so we can see what the value of y is. And now because we've moved our main file to run it, we need to say go run cmd/main.go. So you can see in the console, we get this really weird block here, and this is the memory location for where x is stored. So if we want to print out the actual value of x, now we can use this star syntax, and this should print out 10, where this is going to print out the random block of numbers here. And so this isn't a random block of numbers, this is hexadecimal. And then you can see that we print out 10. Another thing that you'll see in Go a lot is this colon and then equals. And this just means that x is going to be of type int because the value we're assigning to it is an integer. So another way to define x would be to say var x, and then we need to provide the type. So I'm going to call it an int, and then we can say equals 10. So now if we say that x is an int, but it's equal to a string that says hello world, you can see that Go is complaining because this string should be a type of int. But the colon equals is really nice if you can get the type from the value. So you can see that we've done this up here as well. The app is typed as fiber.app, but we haven't actually said that its type is fiber app. It's because it's inferred it because we've used this colon equals syntax. So let's go back to setting up our database connection. So now I'm going to say var mongo once, and I'm going to give this a type of sync.once. And you can see that we've imported sync from the standard library here. And defining these two variables here is a lot like hoisting in JavaScript. So in JavaScript, we might say something like var x, and then x is now undefined. And then later on, we're going to say x is equal to 10. And the reason that we're doing this is going to be obvious later on. So now I'm going to say func get mongo client. And you'll notice again here we have a capital G, and this is because we want to export our get mongo client function here. And our mongo client, and this function is going to return two values. So in these brackets here, this is going to be our arguments, and we're not actually going to take any arguments. But I'm going to have to define some new brackets here. And we're going to say star or a pointer to mongo.client, and we're going to return an error if we encounter an error while trying to connect to the database. So now I'm going to say mongo once.do, and this just ensures that we only ever run this function once, because we're going to be able to call this get mongo client multiple times. But if we're already connected, we don't want to have to reconnect every time we hit a handler. I'm going to say func, then I'm going to say client options is colon equal to options dot client, and options comes from the Mongo driver / options. You can see this import here. Then I'm going to call dot apply URI, and I'm going to define a URI that we're going to connect to. So up here, I'm going to say const, and then I'm going to open some brackets. I'm going to say URI, it's equal to MongoDB : / localhost, and then 27017, which is the default port for MongoDB. I'm also going to define a database string here. I'm going to say database equals products API. So you'll notice these properties here also start with uppercase, especially database, and that is because we're going to want to export this database property here. So URI could in fact actually be lowercase, and this would make it private. So we're going to apply URI, and then we're going to pass in our URI here. Next, we're going to say client, and we're going to do a comma, and I'm going to define another variable here called error. I'm going to do colon equals mongo dot connect, and then I'm going to use context dot to do. Then I'm going to say client options. Okay, so there's a few new things here. So firstly, we have these two properties here. And this is because if we go into Mongo Connect, you can see that we're going to return two items here. We're going to return a client and we're going to return an error. And we're going to return them in that order. So if we didn't want to use our client, but Go forces us to get it because we need to get our error, we can use an underscore. And this just means that we're going to define this variable because we have to get the next one, but we're not actually going to use it. And you can see that Go is no longer complaining about this, but we are going to use our client. The next thing we want to look at is context.todo. So we can command click into this. And context.todo is basically just empty context. So if we have a look at Mongo Connect, you can see that it requires context, but we don't have any context to pass into Mongo Connect. And so we're just going to pass an empty context, and we can do that with context.todo. Next, I'm going to say that our client instance is equal to our client. So if we have a look up here, we have our client instance, which is a pointer to mongo.client. And this is exactly what our client is down here that is returned from Mongo Connect. Next, we want to say client instance error, and we need to define this client instance error. So let's go do that up above. I'm going to say var client instance error is a type of error. And then we're going to make our client instance error equal to our error. And then from our get Mongo client, we just want to return client instance and client instance error. That's then going to satisfy these two return properties here. So let's move on to creating our handlers. So inside of our handlers folder, I'm going to create a new file and I'm going to call this products.go. And I'm going to set the package here to handlers. The next thing I'm going to do is to define a struct. And a struct is a blueprint, essentially, for an object. JavaScript doesn't really have anything that's like structs, but if you've used TypeScript, a struct is a lot like an interface. So I'm going to say type product, and then I'm going to say struct, and then I'm going to open up some curly brackets, and inside of here, we're going to define our struct. Just note the uppercase P because we're going to want to export this product struct. So next I'm going to say ID, and I'm going to set the type of ID to a primitive, which comes from the MongoDB driver, dot object ID. Next, we want to provide some backticks, and we just want to provide some BSON types for this. So these backticks essentially just take a string, and then that string can be used by any package to handle certain things around this struct. So we're going to say BSON, and then I'm going to use a colon, then some double quotes, and I'm going to say underscore ID. So BSON here has nothing to do with Go. It's something defined inside of the MongoDB driver. So the MongoDB driver is going to look at this string here, and this is going to say, okay, in BSON, this is underscore ID. But we also want to provide a JSON type for this. So I'm going to say JSON, and then I'm going to say colon, and then I'm going to do the same. I'm going to call this underscore ID. So I'll show you later on what happens if you don't provide this JSON property here. Let's move on to created at, and I'm going to set the value of created at to time. And this comes from the time package, which is part of this standard library. And then I'm going to say dot time. Then I'm going to say JSON colon, and I'm going to call this created at. Then I'm going to say BSON. It's created underscore at. I'm going to do the same with updated. I'm going to say that this in JSON is called updated at. And then in BSON, it's going to be updated. The last property that I'm going to create is a title, and the title is just going to be a string. And then in JSON, this is going to be called title. And then in BSON, this is going to be called title as well. Okay, so now that we have our product struct, we can define our handlers. So I'm going to say func create product. And then if we go back to our main.go, you can see that our health check handler here takes this fiber context and we've called it C. So we can copy that and then we can come over and we can assume that create product is also going to take the same property. So we need to import fiber, and you can see that VS Code has imported that for us. So the next struct that we're going to use is func get all products. And then we're going to do the same. We're going to call C, and this is going to be of type fiber context. So something that you'll see a lot in Go, but you won't see so much in Node, is this single letter variable names. So you can see here that we're calling context C. And if you were using just JavaScript, you would just have C here, and you would have absolutely no idea what C is. But because we're defining a type here, and you can command click into this type and see the full struct, it's generally okay, and some people consider it best practice to provide these really short variable names. You'll get used to it over time, and it won't be so bad. Next, I'm going to create a product, and I'm just going to call this product, and I'm going to say colon equals, and then I'm going to call my product struct, then I'm going to use the curly brackets. So what we're doing here is we're defining a type, and so for that type, we're going to provide some properties. So in JavaScript, you wouldn't have this product here, and you would just say my product is equal to this object. In TypeScript, you could do something like this, where you would say that our product is of type product and it equals this object here. So I'm going to provide a couple of properties here. So I'm going to say ID, and ID is going to be primitive. And then we're going to call new object ID. Next, we're going to provide a created at, and this is going to be time.now. Then we're going to do the same for updated at. And you can see that VS Code is giving us some really helpful hints here. And this is because it knows that we're creating a product type here. And so it knows all the properties that are going to be on this product. You will also notice that we're not providing a title here, and that's because we're going to get it out of the request body. So let's do that. So I'm going to say if error, then I'm going to assign that to c.bodyParser. Then I'm going to pass the body into the product that we just created. Then I'm going to say error is not equal to nil. Then we're just going to return an error. Okay, so what's going on here? Firstly, we're saying call c.bodyParser and then pass the body into the reference for our product up here. Then we're saying if the error is not equal to nil, then return the error. And we're getting a warning here because no return value was expected. And that's because up here, we're going to say that this function is going to return an error. So this syntax here is really confusing, but I think an easier way to break it down would be to say that you want to assign the error to c.bodyParser, and then you want to move this portion down. So you can say if error is not equal to nil, then we're going to return our error, and then you can remove that here. But the syntax that I had earlier is something that you'll see really commonly in Go. So I'm going to comment this out here, and then I'm going to bring back the other syntax, and then I'm just going to say could also be broken down to be. So you know when you see this syntax here, this is what it's actually doing. Okay, so next I want to use our client that we created in our database. So I'm going to say client or error is equal to DB. You can see here that we get an import for DB, and it's at example.com/tomdoestech/internal. We can have a look up here. /db. So the reason that it's at this path is because in our go.mod, that's what we defined our module as. It doesn't necessarily mean that this module here is hosted at this address, although it generally should mean that. Then I'm going to call .getMongoClient. Then I'm going to say if error is not equal to nil, then I want to return the error. Then I want to say collection is equal to client.database. Then I'm going to call db.database. And this is the database that we exported earlier. You can see here it's called products API. Then I'm going to say .collection. And then I'm going to call db. And we don't have a products collection in our database. So let's go create that. And this is essentially just an enumerator. So I'm going to say const. Then I'm going to call this products collection. It needs to have a capital P because we're going to export it. It's going to be a string and it's going to be called products. So this is going to work perfectly fine. However, a more reliable way of doing this would be to define products collection as a type. So I would say type products collection is a string. Sorry, I would just call this collection. Then I would say products collection is of type collection, which is a string, and then it's equal to products. And the reason that I would do this is because these work like enumerators, and you can get some pollution in other parts of your application. And to avoid that, you can just define this type up here. So if I had other collections, for example, let's say that I have a user collection, I would just say the user collection is of type, again, collection, and then I'll call it users. Let's go back to our products and I can say db.products collection. And products collection is just going to be a string. And so VS Code has kindly wrapped it in this string for me here. Next, I can say underscore and error is equal to collection dot insert one. And then again, we're going to use context dot to do. And that's because insert one requires context, but we have no context to pass in. We just want to pass in an empty context, and we can do that with context dot to do. Then I want to insert the product that we created earlier. So you may be wondering, I haven't defined a title on here. How is product going to get inserted? Because our product struct requires a title. And the reason we can do this is because we're calling body parser and we're passing our body onto our product object here. So this is the syntax that I was talking about earlier. We have this underscore here. And if we have a look at insert one, you can see that it returns the insert one result and an error. We don't want the result, we just need the error. And so we just use an underscore here to keep Go happy. Then we're going to say if error is not equal to nil, then we just want to return that error. Otherwise, we just want to return our product. So I'm going to say return c.json. And then I'm going to return the product. So let's hook this handler up to a route. So I'm going to come back to main.go, and then I'm going to say app.post, and then I'm going to set the path as /API/products. And then I can say handlers dot create product. So if we have a look here, we scroll up, you can see that VS Code has imported the handlers from internal/handlers for me. And one really cool thing is because in our product handler, we set the package to handlers, we don't have to call anything like handlers.product.createProduct or anything. This create product function is just part of the handlers package. So if we had another file in here and it was called, say, users, and we set the package again to handlers, then on handlers, we could just use all the functions that are inside of that users handler. So let's start our server up again. So I'm going to run npx kill port 3000, and that's just to make sure that we kill any process running on 3000. And then I'm going to run go run cmd/main.go. So our application has started up now. I'm going to set the body to raw, and then I'm going to set it to JSON. And you can see here, I'm just setting a title. This is a product title. Send that request, and you can see we get back a object here, and that's because it's been inserted into the database. So what happens if we just send this with an empty payload? Yep, we get back a title, and this is an empty string. This is not really what we want to do. We want to make sure a title is present before we insert the product. So let's add some validation. So I'm going to define a new struct. So I'm going to say type error response. And then I'm going to say failed field. This is going to be a string. I'm going to add a tag. It's going to be a string. I'm going to add a value. It's going to be a string. Next, I'm going to create a function for validating products. So I'm going to say func validate product struct. Then I'm going to define a variable called p, and this is going to be of type product. And then this function is going to return a slice of our error response. So I'm going to say var errors is equal to a slice of our error responses. So when I say slice, basically what I'm saying is array. In Golang, they call it a slice, but essentially it's just an array. So then I'm going to say validate is equal to validator. And you can see here that validate is going to come from go playground/validate. So VS Code is going to have imported validator from github.com/go playground/validator, but we want /v10. Then on validator, I'm going to call .new, and I'm going to execute that function. Next, I'm going to say error equal to validate dot struct and I'm going to pass in p. So next I'm going to say if error is not equal to nil, then we're going to loop through all the errors we get, and then we're going to populate this errors slice here. And then at the end, after our if statement, we just want to return our errors. So we have one little error here, undeclared variable name validator. Reason is that we need to go get this module. So let's say go get, and then we can paste in the path to the module, and it's going to go ahead and download it for us. And then that's going to fix that error. Okay, so I'm going to use a for loop to loop through our errors, and then I'm going to populate our errors slice here. So I'm going to say for, and then I'm going to use underscore because I don't want to use the index. And I'm going to say error is equal to range error dot. Then I'm going to call validator dot validation errors. Then I'm going to say var element is going to be of type error response. Then I'm going to say element dot failed field is going to be equal to error dot struct namespace. Then I'm going to say element dot tag is going to be error. It's going to be equal to error dot tag. And if you're wondering where I'm getting this failed field and tag and everything, we define this on our error response struct up here. So the next one that we're going to get is our value. So I'm going to say element dot, and you can see here that it says value. And the reason that VS Code knows about that is because we've said that element is of type error response. So this is going to be error dot param. Then I'm going to say errors. It's equal to append, and we're going to append errors. And then we're going to append our element. Let's come back down into our create product handler. And I'm just going to say errors is equal to validate product struct, and I'm going to pass in our product. Then I'm going to say if errors not equal to nil, then I want to return c.json, and I want to return our validation errors. So you may be wondering, how does the validation function know what to validate the struct against? So for example, how does it know if we don't provide a title that title is required? So remember before I was saying that these tags here are really flexible? Well, our validator is going to look at these tags and it's going to see if we have certain fields in here, and then it's going to have a look at our payload and make sure it matches those fields. If you wanted to do something similar to this in JavaScript, you would use a package such as yup, joy, or zod. So we can go into the validator. So inside the validator package, you'll see this baked in file .go, and we have baked in validations. You can see here we have a bunch. So it says required, required if, and required unless, and there is some documentation on this package, but I'm just going to use a few of these baked in validation functions here. And if you want to have a look at the implementation, you can see here we have required, and then required is has value. And then you can see the full implementation of this has value function. So up at ID, I'm going to provide another field here, and I'm going to say validate. And then I'm going to do colon, quotation marks, and then I'm going to say that this field is required. So we have three properties here. One is JSON, one is BSON, and then one is validate. So we can copy our validate and we can paste that. So we can see that all of our fields now are required, but for my title, I want to set a minimum character length of 12. So after required, I'm just going to do a comma, and then I'm going to say min is equal to 12. So let's stop our server and restart it. So we can go back to Postman now, and I can remove our title and send this request along. And you can see that we have a field that failed, and that's product.title, our tag is required, and then our value. Let's have a look and see if we set it to something that's only 3 characters long. And you can see here we have product title, the tag is the minimum, and this is the tag that failed, and the value should be 12. Try to send this along again, and you can see that we've created a product. So before I said that I would show you what this looks like without the JSON fields here. So I'm just going to remove the JSON field for a couple of properties here. And then I'm going to restart the server. And if we come back to Postman, you can see now that we have ID and created at, and created at has an uppercase C, and then ID is all uppercase. And the reason is because if we don't say that in JSON explicitly, we want this field to be called _ID, then it's just going to use the property name on the struct. So the last thing to do is to implement our getAllProducts handler. So if we have a look at what overlaps we might have with our create product, you can see here that we're defining a client. So we're probably going to want to do that. And then we're going to make a database call, and then we're going to get a collection, and then we're going to make a database call, and then we're going to return the result of that database call. So I'm going to say client and error is equal to db.getMongoClient. Then I'm going to say var products, and this is going to be a slice of type product. So I'm going to say if error is not equal to nil, then I simply want to return the error. And we know we're going to get an error here because we don't tell Go that getAllProducts should return an error. Next, I want to say collection is equal to client.database. I'm going to say db.database.collection, db.productsCollection. And then I want to say CUR, which is a cursor. And then we're also going to get an error, is equal to collection.find. And we're going to use context.todo. And again, we're just going to use context.todo because we want to provide an empty context. Then I'm going to say bsign.d. Then I'm going to open up some brackets and I'm going to say primitive.e. And then I'm going to provide some brackets. So the reason that we're going to do this is because we're not going to provide any arguments inside of our find. If you were to provide some arguments, say find products that have a price greater than 3, then you would provide those arguments inside of here. But we're not going to do that. Next, we need to check our error. So we're just going to say if error is not equal to nil, we can copy and paste that. Otherwise, we're going to iterate through our cursor. So I'm going to say for cur.next. Then again, I'm going to say context.todo because we want to provide an empty context. Then I'm going to say var p is of type product. Then I'm going to say error equal to car.decode. Then I'm going to decode the cursor value into p. And then if this decode returns an error, we're going to find it here. Then I'm going to say if error is not equal to nil, then we want to return the error. Otherwise, we want to append this product onto our product slice that we defined above. So I'm going to say products is equal to append, and we're going to append to products, and we want to append our current product, which is a pointer to p. And then finally, after we've iterated through all the cursors, we just want to return c.json, and then we want to return our products. Okay, so let's hook up a handler to this. So instead of a post, I'm going to create a GET request. And the route is just going to be /API/products. And then the handler is going to be, of course, get all products. So let's go try this function here. So let's send this GET request to /API/products. And you can see that we get a list of products back. So that's the basics of creating a REST API with Go. The last thing to show you is how to use middleware. So in Express, you have the concept of middleware where you can use app.use, and then you provide a function here and say console.log hello from middleware. And we need to obviously move that above our route calls. And then you would have your request, your response, and next. And you would just need to call next so we can move on to the next handler. In Fiber, we can use middleware as well. We can say app.use, and then we can provide a route that we want to use this middleware on. So I'm going to say /API. And then I'm going to provide a function. And the function is just going to take Fiber context again. So it's going to be C and then Fiber dot context. And then I'm going to say fmt.println hello from middle. And then we of course need to return next. And this is so we can move on to the next handler because this is just middleware. So then we can return c.next. And Go is telling us that we have an error here, and this is because next might return an error. So because we're using the return keyword, we need to return an error here. And that is how you use middleware in Fiber. If you want to see more Golang tutorials related to JavaScript or backend web development in general, please let me know in the comment section below. If you found this video helpful, please make sure you subscribed and leave a thumbs up. Thank you for watching, and I'll see you in the next video.